Sir, we are not.
Okay. So, cancel. Okay. I thought it was like simple, but okay. I need to share the window now
Yes, sir.
and take presentation. Okay, we'll start from here. Maybe can you see my
Yes, sir.
slides
Perfect.
now?
Yes, sir.
Or you can see my slides, right?
Yeah, your window, sir. Your AI presentation window.
No, but can you see my PowerPoint slide? No.
No, sir. You are. We are seeing the open folder AI presentation and
Yeah,
artificial.
there's something definitely wrong with this. I don't know. But
Okay.
I was trying to share my window and okay. Damn, maybe. Because I've opened this in Google Chrome, and so that's the problem. I think I can only share one of the windows in Chrome. Okay, there you go. Ah, finally.
Okay.
Can you see this now?
Yeah, sir. Perfectly.
So this was my brief introduction, which was given by Himanshu very well. I'll just repeat things once again. That I was graduated from IIT Roorkee, the university which was established in 1847, which was like more than 150 years from now. Um, I did my graduate studies, which is PhD from University of Auckland in New Zealand, which was again established in 1883. So I think 1883 has done more than 150 years, and IIT Roorkee probably has done more than that. So, but these days I'm working in a comparatively new university. It's called Nazarbayev University, which is a flagship research university of Kazakhstan. The university is adopting a model of NUS, National University of Singapore, and it aims to achieve uh, times higher education rank very soon. So I'll start with a brief introduction of my university here. Sorry, yeah. So with this, okay. So I'm going to talk on artificial intelligence today. The idea of showing this small video on my university before my presentation was that more and more students, those who are willing to take up further higher education abroad, can consider this university because very soon this university will be offering very attractive scholarship to master students. So those who want to pursue MTech, Master in Technology, can consider this university, and the kind of scholarship that they are aiming at around will be around $500 to $600 every month, which is sufficient for the livings. And then there are avenues to do PhD, and the university has 500 professors who come from 55 to 60 different countries. So, well, back to our presentation on artificial intelligence. I'll start it with the data analytics definitions and description, and then I'll talk about the difference between artificial intelligence and the machine learning. We'll try to give an overview of artificial neural networks, and then with an example, I'll try to draw a rationale of deep learning or deep neural networks, and then explain it a bit. So as we all,
सर वॉइस प्रॉब्लम या आवाज नहीं आ रही.
okay, wait. Can you hear me now?
Yes, sir.
Yes,
Okay,
sir.
okay, good. So, but can you still see me? Can you still hear me? Because I'm presenting in a full screen mode. Am I audible?
Yes, sir.
Yes, sir.
Okay, good. Thank you. So, when we talk about data these days, we have been collecting a lot of data. So we need to understand what are different types of data, and what ultimately computer wants from the data, what form computer wants these data in, and then what wonder can be achieved through the data analytics. I mean, previously for engineers, if you remember, the highest salary, highest paid jobs were like for a software engineer. So we had seen like even civil engineers, mechanical engineers, everybody's running for for these kind of software related jobs to become a software professional. But in times to come, these software engineers jobs positions would be converted, and they've already been started. They already started converting into a data analytics job. So what we had a software engineer before would be now called a data analytics engineer, and that's the power of data that we've been collecting. So we all understand that processing data, you can get information, and this information. Hello. So now, if you talk about artificial intelligence, it basically relies on a lot of data. So first, we need to understand what are different kinds of data. So here, I'm trying to show that the data could be alphanumeric, right? It could be an image data. It could be some sort of animation, or it could be a sound data, voice data, or it could be a video data. So the data could be textual in a text format, or in an image format, or in a video, which is nothing but a collection of many frames, many images. Now, all these data, they have to be converted into a language that the computer can understand. And that language is basically a binary language. So we try to convert everything, give it to the computer in a form that the computer can understand it. Now, when you perform data analytics on the collected data, I mean, this data could be collected from many sensors, or it could be recorded, or it could be, so even if you're putting a CCTV, we call it an image sensor. if you're measuring temperature outside, we use sensors. So we use a lot of sensors these days, uh, and they try to collect data. If you go to a mall, you would find that the clothes that you purchase would have some sort of attachment that the um, that the person selling it has to remove it and give it to you. If they don't remove it and you try to come out, there'll be a beep sound, and then they'll find that they've done some mistake. So basically, they have all these clothes. They have RFID attached to them. So what this radio frequency identifiers is, like, they're all sensors again. So I mean, if you look at even your house, there'll be sensors. Go to industry, they use a lot of sensors. So these days, more and more sensors are being used, and so we collect more and more data as well. Now, with the data that we have collected through sensors, we can perform data analytics, which normally is of three kinds. The first type of data analytics that we can perform on this data is called descriptive analysis. It's like what is happening and what has happened, like what's going on. So if you process the data simply and try and find relations, then probably you would know that what is happening. If you if you continue the same way, if you don't change your system, if you don't change your procedures, what could happen in 5 years to come or 5 months to come? That is something called predictive analysis. And if you don't want to, continue with the same procedures, because with the same procedures you're not earning more profit and you want to earn more profit probably, then you would try to change your ways, and then those guidelines or those indicators can also be obtained through artificial intelligence. That I want to increase, you can always speak to your computer and tell it that I want to increase my profit 2 times in 5 years to come.
Sir, voice is not clear.
Can okay, or maybe if I'm speaking loud, probably it helps. Is it better now?
Yes, sir. Yes, sir.
Yeah, thanks. So this kind of prescriptive analysis can also be done using artificial intelligence. That if you want to achieve a different objective or more profit, what needs to be done in in while analyzing the data or performing the data analytics. See, there's a difference between data analysis and the data analytics. The data analysis means that you have the data and you're trying to infer some information from the data. That is data analysis. But data analytics is data analysis plus modeling. So if you have data and if you're analyzing the data, and then you're coming up with a model of the system. I mean, the data is coming from a plant, from a system, right? So if you're able to model this plant or the system, the entire process of data analysis and modeling is called data analytics. And there what we do is we first try to identify what data is important, and then we collect the data, we acquisite the data. After collection, we process the data to remove the noises and try to get the important information that is required. And then after processing and cleaning, we try to create a model of the system where the data is coming from. Now, this is all. I mean, these first 10 slides, I think, will be from our previous last year's discussion, but still, these are important because to continue with the flow, which I'll be taking after these slides, it was important to give you the background. Now, of course, data analytics is important because most of these sectors, including healthcare, consumer energy, manufacturing, etc., they all been using it, and mostly data analytics is used by the finance and the banking. Finance and banking, their only raw material is this data, and so they have to work with the data to get the predictions for the day, for the week, for the month. And so they are the biggest customer for the data analytics. Now, the basics of data analytics, as I said, goes. Starts from data identification, collection, cleaning, processing, all that. The important part of the data analytics is this modeling, which can be carried out using machine learning or artificial intelligence. Now, if you talk about, as such, there is no difference between machine learning and artificial intelligence. The both approaches needs classification of data and then regression of the data. Where classification is quite simple, it's just labeling of data. You should know what are inputs and outputs. The regression, it helps in mapping. It helps in finding a relation between the inputs and the outputs. It's quite simple. For example, if you are able to see my screen, I have certain data. The data has to be passed through a classifier and get some inference, get some knowledge. Now, the data is about. The data has been given in a table where the first column is for the names of the people. The second column has their ranks. Third column has number of years they have worked, and the fourth column says whether the person is tenured or not. Tenured means a permanent job. Normally in universities they have a contractual work, and there are few people who are tenured. They are permanent. Not, unlike Indian system, in Western systems, they don't give a permanent job to any faculty. So initially they'll remain on a contract. Now this algorithm on your screen says that if the person has worked for more than 6 years, he should be tenured or he should be made a permanent faculty. Or otherwise, if a person has a professor rank, full professor rank, then obviously he'll be given a permanent title, or he'll be tenured. So these are the rules that we have, and based on these rules, the classifier would classify the entire information. So we know that a certain person on certain rank with certain number of years of experience, whether he's permanent or not. So it's basically, classification is nothing more than the labeling of data, and that has been done. And after this labeling, there will be a regression performed onto this data. The regression would learn the underlying relation between inputs and outputs, and then for any new information that you come across, that a professor has, a faculty has such and such years of experience and his rank is so and so, then the regression model will quickly tell you whether the person should be tenured or not. For such kind of a regression and classification, we can use machine learning algorithms, which basically are supervised or unsupervised. The supervised machine learning algorithms simply means that the data has been properly labeled and we know what are the inputs and outputs. Whereas for unsupervised machine learning algorithms, these are applied to the case where the data is not labeled and we do not know what are the inputs and outputs. So we need to, of course, we need to perform the data analytics. We need to create a model of the system, but at the same time, we also have to find out what probably could be the input data and the output data. Now, in the category of supervised machine learning, there's number of algorithms that one can work with, starting from linear regression, logistic regression, random forest, gradient boost. There's a number of algorithms for supervised machine learning, but for the unsupervised machine learning, because of the nature of the problem, there are not many algorithms, but there's still the important ones are this k-means clustering and the principal component analysis. Now, you may have such kind of question like, what if artificial intelligence and machine learning, they are both doing the same job, that is creating a model of the system, then what is the difference? Now, the difference is still quite significant. Though, I mean, if I can explain this in a nutshell, because I don't think the time would permit us, so I need to go fast. The difference basically is that through machine learning, you can understand the system, and then you don't need to operate the system. You can just simply take this machine learning model, give it inputs, and then it'll give you the outputs. But if the system is slightly changed over time, or if there are some new things added to the system, then your machine learning algorithms cannot adapt, cannot change. Whereas the artificial intelligence algorithms, they learn the system, they model it very well, and if there's some small changes in the system, the artificial intelligence techniques would be able to adapt and would still be able to work and give you output for unknown inputs. So that's the basic difference. Machine learning, it only learns the system and does the modeling. Artificial intelligence, it understands the system and can still work if the system has changed a bit. Now I'll give you basic overview of starting from artificial neural networks, and then we'll see how why we need deep learning later on. So here actually I wanted to tell you that using machine learning, you basically need two different algorithms, for one for feature extraction or classification, and then that and then you need another algorithms for regression. So when you're using machine learning, you need one algorithm for classification, there's another algorithm that you need to use for regression. But if you're using deep learning, or if you're using any other artificial intelligence approach, both classification and the regression can be carried out with a single algorithm in a single run. So that's again gives edge, gives benefits to artificial intelligence techniques over machine learning. But having said that, I'm not telling you that the artificial intelligence techniques are always better than machine learning techniques. Sometimes, depending on the type of the data and the application, machine learning approaches can also give you better accuracies and reliability. So, as I was telling you today, we'll discuss basics of neural networks, go through an example, and then we'll try to find out why we need deep learning. So, we all know that in artificial neural network, what we basically do is we try to create a model of our brain, how our brain works, and so it is a good idea to understand our brain first. Now, the brain is the most complicated thing in the universe, but but we're still trying to understand the basic entity in our brain that is called neuron, and we'll try and see how the neuron works and can be modeled into mathematics. Fine. Now, our brain basically, it has more than 1 billion of neurons. It may not sound large enough, but 1 billion is actually really large. It's like um, thousand, and thousand. So it's like really there are many, 10 to the power 10. Now, with so many neurons in the brain, and every neuron is further connected to more than 10,000 neurons, it's like very highly connected, interconnected, and complex thing. There is no other complex thing in the world more than the brain. Now, despite all this, the average brain says that it's very lightweight, like it weighs only 1.5 kg. And if you talk about the energy consumption, the kind of work your brain does, if you try to get the same amount of work from a computer, it would consume 15 million watts, whereas your brain consumes somewhere between 10 to 15 watts. So it's a difference of the order of 4. Now, basically, your brain has so many neurons, and every neuron, it has few parts, starting from the end part, which is called dendrites, and then moving back. I mean, the dendrites are there to catch the information, to receive the information, and the information is passed through. Okay, I'll go to the next slide. Now, as you can see in this diagram, the dendrites, they collect information, and then the information is passed to the synapse. If the information is important, then it will be given more weight. If the information is less important, it will be given less weight. And then the information is passed to the cell body, which is called soma of the neuron, and then the axons are there to give you the output. In a sense, I have provided one small diagram here to explain what one single neuron out of those 1 billion neurons, one single neuron, what it is doing. It's basically collecting all the inputs, these x1, x2, x3, and x4. These are the inputs. Now, inputs are attached with certain weights. If there's some information which is important, you would remember it for long. But if there is information which is not significant, you would forget in few hours. So it all happens because of these weights. The size of synapse would decide whether the information is important or not. And then the entire information is summed up. So all these inputs are multiplied by the weights, and then they are summed up, and then the information enters into the cell body, and then the cell body, so the cell body will give you an output, which in mathematics we can model it as if some sort of this information going through some sort of a thresholding function. So here, as you can see, this phi is some sort of thresholding function. What this function is, we'll see in the next slide. Now, for instance, if I ask you to multiply 5, 3, and 2, your immediate answer would be 30. So in the process, I'm sure you have not actually multiplied it, but the answer comes immediately because your brain has been trained. And so whenever the information 532 and the multiplication goes into the brain, it would the brain would multiply it with certain weights and pass through certain function. As in this case, I have this 10 hyperbolic as a thresholding function, and then it'll give you the output immediately. So all we need to do in designing this kind of a neural network, we need to identify what these weight matrices are. So normally when we talk about multi-layer artificial neural network, I'm just going quickly because this is all very basic information and all of us already have it. So I don't have to go into the details. I can simply say that the multi-layer artificial neural network means that we are trying to copy our brain, copy how our brain functions. And because our brain also has layered construction, the brain has these neurons, they are arranged on various layers in our brain. So similarly, we also use layers here. So the first layer is called input layer, and then we have the last layer is called the output layer, and whatever in between input and outputs you have, they are called hidden layers because they are hidden between input and outputs. So input layer receives all the inputs, and then the inputs are multiplied with the weights and given to the hidden layer. So definitely there's a weight matrix between input and the hidden layer. And then hidden layer would process this information, pass it through certain function, and then we'll give it out. And so the output of hidden layers is again multiplied with some certain weights to go to the output layer. So definitely there is another weight matrix which lies between hidden layer and the output layer. So we got two weight matrices there. If you have one hidden layer, there will be two weight matrices, one between input and hidden layer, and the other would be between hidden layer and the output layer. So all we need to do is we need to identify this weight matrix, and then the model is complete. So I mean, those who attended the previous session last year would understand this, that we did develop a simple code in MATLAB, and we've seen how this kind of weights identification of these weight matrices using gradient descent learning is achievable, and we've seen this code how it runs also. So I'll not repeat again. What I'll try and explain is how these weights are updated. So initially we start when we initialize this modeling, we start with random weights. So to start with, the weights are assigned randomly, and then later on these weights are changed so that the error in the model output and the data output is minimized. So for instance, as you can see here, um, there are three inputs. So these three inputs are multiplied with three weights and are given to a neuron. The neuron inside has a thresholding function. This function is basically, if you talk about human brain and how it works. So if you try to model it, it is apparent that the brain function is quite close to the sigmoidal function. So the function on top here, as you can see, is 1 over 1 plus e to the power minus x. It's called sigmoidal function, and it quite closely models how our brain works. So this x enters in here into this function, and whatever is the output will be your function output. Now, for instance, let's say I've got some random weights which are 2.7 minus 8.6 and 0.002. So collectively, the inputs multiplied by the weights would be 21.34, and if this 21.34 is plugged into this thresholding function, sigmoidal function, the output would be something like 0.999. Okay. Now we'll see further. For instance, let's say you have such kind of a data set where you got input vector in a 1/3 vector, and then the output is basically binary. Okay. So for inputs as 1.4, 2.7, and 1.9, the output should be 0. Whereas for inputs as 6.4, 2.8, 1.7, the output should be 1. Okay. Now, when you're trying to train this neural network, so basically we work with the data. The data is given to the network, and we try to train. So what do you mean by training the neural network? It's basically we are trying to identify a correct weight matrix between input and hidden layer, and a correct weight matrix between output and the hidden layer. So sorry, yeah. So the first thing that you do is you need to initialize the random weights. Okay, good. So we initialize the random weights. See, my first input was 1.4, 2.7, and 1.9, and the output should be 0. Now, so let's say when I calculate with my random weights, the output comes out to be 0.8. Now the output should be, I mean, this is the output from the model, but if you look at the data, the output should have been 0. So instead of 0, I'm getting 0.8. So there's of course an error of 0.8 here, which has to be corrected. Now, how in order to remove this error, or in order to make this 0.8 at 0, what you need to do is you need to change these weight matrices. You need to correct and repair these weight matrices as shown here, and then you would be able to get it. For instance, there's another set of inputs which is like 6.4, 2.8, 1.7. The output should be 1. Now from your model, let's say from the assumed weights that you have, let's say the weight that we repaired from the last observation. Now the model gives you an output of 0.9, but your actual output should have been 1. So there's again error of 0.1 that has to be corrected. And how do you correct that error? Once again, you'll have to change the weights, and the error can be corrected. Now these are just two instances I've explained, but there'll be, I mean, this will be repeated for 1,000 and I don't know, 100,000 times, and then making those slight small adjustments into the weights. Eventually you'll get a weight matrix which will give you perfect output for unknown inputs even. So if you want to understand how this artificial neural network it works on the error and how it decreases error, there's a very nice boundary perspective given here. So this will explain you how this weights are changed and accordingly the error is minimized. So with time, as you can see, when you're training the data, eventually you'll be able to differentiate between the data, and this is how you'll find that your artificial neural network can understand the patterns into the data. Now, basically, this training algorithm of ANN, we call it a dumb algorithm because it will only understand what the data is, and it will understand the pattern in the data and will give you the weight matrices. So, but it really helps us, but we need to make it more intelligent. So, as you can see, we just need one hidden layer even if our function is a non-linear, and we can actually solve many of the existing problems using artificial neural network with just one hidden layer. All we need to do is, of course, there's a set of weights that exist and that can produce the target from inputs, and the entire exercise is to finding them. But I just forgot to add one more thing, that the weight matrices that you find using the artificial neural network is not unique. There can be more than one answers. It is possible that that I'm training certain data and coming up with a weight matrix, but there's another person who trained his artificial neural network with the same data again, but maybe his initial points were different, and so he would even get a slightly different weight matrix, and this is really possible. Now I'll switch to a MATLAB example. So what I'm trying to do here is, if you're still able to see my screen and if you're all with me, I think I have time until 11 today. So we still have 45 minutes to go through. Good. Now, in this example, what I'll try and explain here is that we'll be developing one small artificial neural network, a multi-layer perceptron, to identify the alphabets in English language. So there are 26 alphabets, we all know that. But I'm just explaining you how to identify these letters. So the model that we create, it'll be given certain information in binary, and the model will tell us whether the binary information it belongs to a certain letter in English alphabet with starting from A to P. I'm only considering 16 letters for now, but those who are interested can work on this exercise and and can create similar algorithm for the entire 26 alphabets of English language. Now, so as I said, we'll use this neural network to train and recognize the letters of alphabets of English language. First 16 letters are identified using 5x7 template. Now, what I mean by 5x7 template is this. So what I'm doing is I'm taking 5x7 matrix, and the boxes in this 5x7 matrix, they are painted. So those boxes which are colored with black, they can be taken as if you talk in terms of binaries. So these black boxes can be taken as ones, and the empty boxes or the white boxes can be taken as zeros. Okay. So to represent letter A of alphabet, I'm using this 5x7 matrix. Okay, and some of the boxes have been colored. Fine. So the template is 5 by 7, and then the vector can be stored. So if the 5 by 7 template, the template would have 35 boxes, right? So all I need to give information to the computer. The information can be given to the computer in terms of binaries, right? So all I need to give it is 35 bits of binary. So if you look at this last line, oops. So a letter can be basically defined as 001, 0001, and so on and so forth. So with 35-bit binary, I'm able to define any alphabet of English language in a 5 by 7 bit template that I have explained. So what I'm trying to do is I'm trying to create an artificial neural network model which will take input these 35-bit binary and will give me an output in terms of whether the letter is A or P or H or N, whatever. Now the output, as I said, I've got 16 letters A to P. Okay, starting from A until P, there are 16 letters. Now the computer can only give me an output in terms of binaries. So my output vector becomes a 4-bit binary. So if it is a 4-bit binary, if you convert 4-bit binary to decimal, you'll get 0 to 15. So I've got 16 classifications. Now the artificial neural network that I'm trying to design takes input as these 35 bit binary and will give you an output with 4-bit binary. So the 4-bit binary would tell me whether the letter is A. If the 4-bit binary as an output I'm getting is 0000, that means it is A. And if it is 1111, that means the output is P. Okay. If you have any question, if you don't understand, you can actually stop me in here and I can explain it in a different way. Now, what I'm trying to do here is that the artificial neural network will be trained. So I need to collect a lot of data first. Okay. So for that, I need to switch to MATLAB maybe. For a minute, I'll stop sharing, and then I'll try and share my MATLAB window. Now, you'll have to tell me again if you're able to see my MATLAB window here. Okay, thank you. So as long as you can see my MATLAB window, you would see that the file I'm working with is called try letters. So, to train a neural network, you first need a training data. So let me create a training data first, because you would, when you start working with this, you probably would learn more. I'm trying to load a file which is called letters, and when I click here, in the workspace, if you're able to see, in the workspace, I've got T as the target vector and X as the input vector. So this input vector, as I was trying to explain, it goes for 16 alphabets in English language. So the first column is for A, second column is for B, and so on and so forth. The last column, 16th column, is for letter P. Okay. So with 35-bit binary, I'm trying to define English language letters. So these are the inputs. Now for the outputs, I have again 4 by 16 matrix. So every column, the first column is for letter A, second column for B, third column for C, and so forth. Why is it so? It's because the first column has 4-bit binary, which is 0000. So when you convert it to decimal, it will give you 0. So 0 is 0 denotes a alphabet. In the second column, the binary is 0001. So when you convert it to the decimal, it will give you 2, which means the letter is B, and so on and so forth. So now I have the data. If you just want to see, I've created a small function here to plot the data as well. So when I say that my inputs are like, for instance, when I'm saying that this is input and 35-bit binary denotes letter A, what I actually mean is that if I plot it, it would look like something A. Okay, can you see this? So when I'm plotting the first column in this 35 by 16 matrix, the input matrix, I would see letter A there. But if I, for instance, if I'm plotting like the 16th column, I should see a P there. Let's see. Can you see a P there? So basically, I have inputs. I've created a database for the training of my neural network, and the database consists of inputs and outputs. Inputs in the form of 35-bit binary, and output in the form of 4-bit binary for identification of the alphabets. This is true, and if you're able to understand this, the next thing is we need to in order to create this neural network, we need to identify the weight matrix, and there are two weight matrices, one between input and hidden layer, the other weight matrix between hidden layer and the output layers. Now these two weight matrices we need to identify, and in order to do so, the first thing that we do is we initialize the weights with some random values. So as you can see, I'm using these random values for weight matrix 1, and then I'm using the similar random values for weight matrix 2. The only thing is their sizes are different. So once I have these weight matrices, say the first weight matrix, because there are 35 inputs and there's one bias as well, and let's say in my hidden layer I've got 10 neurons. So the size of my weight matrix between hidden layer and the input layer would be 10 by 36. Now there's another weight matrix between hidden layer and the output layer. Now because my output is 4 output neurons, there are 4 neurons, and the hidden layer has got 10 neurons, and if you consider one bias there, so it'll make it 11. And so the size of the weight matrix between output layer and the hidden layer would be 4 by 11, and these are there. This is W1, which is 10 by 36. Okay, and the other weight matrix is W2, which has a size of 4 by 11. So the weights are randomly initiated. Now next thing is I need to conduct a backpropagation algorithm and minimize minimize the error. Okay, minimize the error in production, and error in prediction. So when you're trying to minimize the error in prediction, what actually you're doing is you're changing these weights, and so the new weights would be obtained. So here, if you look at this command that I'm using, this bprop2 is basically a function that I've created to carry out this backpropagation training. This x is basically input vector of 35 by 16 matrix. T is the target matrix of size 4 by 16. W1 and W2, as you can see, are the randomly initiated weights. And then you've got 0.05 there, which is my learning rate. Uh, 0.1 is the error tolerance, and number of iterations that I have mentioned is 5,000. Okay. So if I just click it, probably it will do the entire training in no time. I mean, you won't even realize that it has already done it. You can even see what kind of RMS error that you achieve. And I can actually plot this RMS error and show it to you. You would appreciate how quickly this error has been reduced from 0.5 to 0.05. I mean, you can zoom in if you want. Zoom in. So they, and then you have reduced it to 0.05. Good. So the network has been trained, and the weight matrices that we have are the trained weight matrices. Okay. If you take these weight matrices and pass this information, for instance, maybe I'm interested in finding out, say, this was my input matrix, and the first column of 35 by 16 matrix was for letter A. Okay. Now, if I give this as in, it should give me an output. The output should be for letter A, and that means is the first letter, which means that the output binary should be, the 4-bit binary should be 0000, because I'd kept 0000 for A and 111 for P. Now let's see. Okay, this here. What do I mean here is basically this is my input. I mean, the first column in X matrix. It is being multiplied by W1 weight, which is a weight matrix between input and the hidden layer. And then it is passed through a logistic function, as you can see, passed through a logistic function. And whatever is the output, this is the output from the hidden layer, which has to be multiplied by W2 weight matrix again. This W2 weight matrix exists between hidden layer and the output layer. Okay. So output of the hidden layers, from all the hidden layers, whatever you're getting has to be multiplied by W2, and then it has to be passed through another logistic function for that it will become the exact output. Okay. Now in our case, if you look at this, what is the output? It's 0000. It's almost 0000. If I give same 00 input, I should be getting a letter A. I mean, if you convert 0000 to binary, from binary to decimal. Okay, let me see if it is, if you understand this, like, okay, binary to decimal. Binary to decimal, and then you've got 0000. Okay. Oops. Oh yes. Let's say this is B something, and let me change. So the answer is 0. Okay. Oh, decimal is DC. Okay, fine. But if my output, let's say, is 1111, okay, then I mean for a binary, 4-bit binary of 1111, the output should be, the value should be 15, right? So when it is 15, the letter is P. When it is 0, the letter is A, and then you know the intermediary values. For instance, what will be the output for the 7th column, or maybe the 8th column? Yes. So the output is going to be the output is going to be 0, 1, 1, 1. It's like 0, 1, 1. Okay, and when you convert this 0, 1, 1, the output is 0, 1, 1, 1. When you convert this, it turns out to be 7. I mean, it's a seventh letter, which is A, B, C, D, E, F, and then G. This is for G. And you can plot it also if you want. For instance, let me see if I can plot it quickly. The seventh, okay. I hope Himanshu is recording this. So this is D, as you can see, this D here. So if this lecture has been recorded and it is shared by with the participants, probably if you watch it 2-3 times, you would understand more and more what I'm trying to explain. And then
Recording the same thing, sir.
now let's. Sorry. Good. Thank you.
Okay.
Yeah. Now I'll just try to do a trick. You know, of course I've performed the training and the weight matrix that I've obtained from ANN can actually identify all the alphabets. But now what I'll do is I'll try to trick the system. I'll try to you know, fool this training that I've done. Now instead of exactly A alphabet, I'm trying to give it, you know, something which is close to A. It's not A. And then I'll see if my ANN that I have trained can still identify this letter and tell me whether it is close to A or not. Okay. So for that, I have another 35-bit binary there. And this 35-bit binary is stored in small alphabet A. Okay. Now this is A. Now the next thing I'll do is I'll try and find out. For instance, you know, this 35-bit binary that I stored in for small alphabet A is not actually A. It's close to A, as you can see on your screen. It's not A. It's close to A. Now I'll see if my neural network, it should give me an output of 0, 0, 0, 0. So let's see. So output. Now what? Oh, sorry. Now I'll try to find out what will be output if I'm giving A vector as input to my artificial neural network that I've trained. Then it'll be multiplied by W1, passed to a logistic function, sigmoidal function, and then the entire thing that is coming out from the hidden layer will multiply by W2, another weight matrix, and pass through the logistic function. And the output that I get would be, okay, let me get the output here itself. So the output, as you can see, is all 0. It's like 0.200. Okay. Now you might say that maybe it is not exactly you know, 0, 0, 0, 0, but definitely if you give this if you convert this binary and then to decimal, you would get a 0 value, which is like for letter A. Okay, so definitely this is giving me a correct output. So I hope you could understand this. For instance, if I'm trying to find out what happens for like the 12th column of X, if I'm giving it input and if I'm multiplying it with the trained weights, then the output 11 is basically 1 0 1 1. It's like 1 0 1 1. Okay. Now what is 1 0 1 1? Let me check quickly. 1 0 1 1. Okay. 1011. Okay, so obviously this is 11th letter, and so the entire neural network has been trained, and you give it any 35-bit binary and it'll tell you what letter it is close to, what kind of letter it is. Now let's go back to our presentation. So I hope you could understand how. Let me. Okay, I think I need to stop sharing and then share again. So I'm trying to share my PowerPoint here again, and I hope it is uh, visible. So let me check. Can you see my PowerPoint screen?
Yes, sir.
Thanks so much. Now, with this example, we could understand that the neural network can be trained to identify English alphabets between A and P. Of course, we can do it to further extend the problem and identify all the 26 letters, and it's quite simple. But the thing is, we always don't have such kind of simple things, and we'll see what if these letters were written by hand. I mean, if the letters are printed, it's okay, we can find. But when it is written by hand, every one of us will write it differently. Okay, and then if you are asked to write an algorithm, or if you're asked to train an ANN that should be able to identify letters from handwriting, will be still more challenging task. And for such kind of challenging task, because we cannot do all these with the simple multi-layer perceptrons, and so we need deep learning. I'll explain exactly why we need deep learning. But for now, please understand that the deep learning is also known as deep neural networks, or deep structural learning, or deep belief networks. So these are different names for deep learning. And and why we need deep learning is because um, there are many features available in the data, and so we want to identify these features using independent layer of hidden layers of neurons. So for instance, in the multi-layer perceptron artificial neural network that we were using before, used to have just one hidden layer between inputs and output layers. And so we were using, and then we were using weights between these two layers to either strengthen or decrease the weights, or the, the importance of information. That's fine, and it was working well. But the problem is that um, if you have to identify many features, or for instance, if you have to identify many, uh, if you need to model many features at the same time, then you probably need more layers. As has been explained in this figure, you got a picture here as input. So the input layer, it will identify all the light and dark pixel values. There's another layer, it will identify the second layer. I mean, it would identify all the edges in the picture. The third layer would identify all the combinations of edges. And the fourth layer is there to identify all the features. The fifth layer, which is an output layer, would combine all the outputs from various layers to give a collective output that the person is George. Okay. So basically, this deep learning, the so-called deep learning, which is a slight modification of artificial neural networks, it has caused a really breakthrough in speech recognition and image classification. So wherever you have image processing application, you basically would be using deep learning. Um, nothing important here. Yeah. So what is the difference between deep learning and the neural networks is because it's basically that in deep learning you have several layers of hidden, uh, several hidden layers of nodes. Okay. Of course, there's only one input and an output layer, but the hidden layers can be more than one. I mean, they have to be more than one. Now, the different layers and different hidden layers between input and output, they would identify different features. It's quite similar to the way our own brain works. Basically, we are trying to mimic our brain, and so the brain has layered construction, layered structure of neurons, and so there also in deep learning we try to use multiple hidden layers. So now we the previous neural networks ANN that we were using, they had only one hidden layer, as you can see in the top figure there. Okay, but the thing is, and then we use this back propagation to learn the weights there. So the weights between input and hidden layer, and the weights between hidden layer and the output layer. It can be learned using back propagation. But if you're working with many hidden layers, those back propagation or gradient based approaches are unsuccessful. They cannot be used because the one very important and very significant problem, which is called vanishing of gradient. What I mean by vanishing of gradient is that the weights are changed based on the gradient of error with respect to the weights. Now, if you have more layers, then this gradient eventually becomes zero. This gradient of error with weights, it would become zero, especially if you're using sigmoidal and 10 hyperbolic functions, because their range is from 0 to 0.25. If you take their gradients and keep multiplying, I mean, one layer, let's say between 0 and 0.25, another layer is between 0 and 0.25, another layer, and if you continue multiplying values between 0 to 0.5, 0.25, 3, 4, 5, 6 times, it would eventually become zero. I mean, for instance, multiplication of 0.2 and 0.2 would be 0.04. And if you have another 0.2 there, then it will be like 0.08. 0.008. So you need to understand that the gradient vanishes if you have more hidden layers, and so we cannot use those gradient based methods also. So we need to devise something new. I'll give you one example quickly here because we are running out of time now. Only okay, I'll take another 3 minutes and then we'll have question answers. So the problem of handwritten digit recognition is really difficult because the input images, when you try to read on 28 by 28 grayscale, you actually have 784 dimensional inputs. And so if you have, let's say, a hidden layer with 500 neurons and an output layer with 10 neurons, because there are 10 classes, 0 to 9. So you're actually working with 0.4 million weights, or you're working with 4 lakhs of weights, which is very difficult to identify using the low capacity of our computations. So the gradient based descent algorithms, they cannot train it because this vanishing gradient problem, and then the algorithm actually has to identify from pixels to edges to contours to object parts and then object categories and local features and globe. There's so many things that needs to be done. So what we try to do is give each of these tasks to different layers so that different layers can identify different features. For instance, this particular node is there to identify the first row of the first line of boxes, and then it will send a strong signal for top horizontal. So similarly, there'll be different neurons to identify different parts of the image, and they collectively would explain what number it is. For instance, there'll be one layer to identify all the vertical lines. There'll be another layer of neurons in the hidden layer. There'll be another hidden layer of neurons to identify vertical lines and horizontal lines and small circles and so all this. And then there'll be further layers of hidden layers of neurons that has to give you high level features such as all the horizontal lines and the right hand side vertical lines and the upper loop and the lower loop, these kind of information to eventually give you what kind of letter is it is. So having multiple layers do make sense because our brain also works that way. And this deep learning, it's getting an edge over other machine learning techniques. It's because they can identify various features and they are proving to be more accurate. We cannot use the previously, previously we were using the sigmoidal function and the 10 hyperbolic function because of the gradient vanishing problem. These activation functions cannot be used, thresholding functions cannot be used anymore with deep learning, and so we use another kind of activation function which is called ReLU. And this ReLU is actually quite simple to implement. As you can see, with simple one max function you can implement this, and it does not have any vanishing gradient problem, and it has been very successful. The overfitting can also be reduced using L2 regularization. Maybe next time whenever we get more time to to explain, we'll discuss these things as well. So this is the summary of what we discussed today. And then so how we train a deep neural network is that we train the first two layers first, and then the subsequent layers are be trained, and then finally each of the each of the hidden layer, which is not an output layer, they are trained to be an auto encoder. So basically they try to learn some good features from the entire data or feed or image data. And so if you know something about encoders, auto encoders, so for instance this number 2 would be encoded into some compressed representation which can be later on decoded for letter 2. So this is the function of these hidden layers, intermediary hidden layers, and then from the final layer the output would be decoded and will be given. So thank you for your patience listening, and maybe I should stop sharing now. Oops.
Okay, thank you, sir.
Yeah, we can take up questions if we have. Do we have questions now? We still have 5-7 minutes for questions. Actually, yeah, I wanted to give more time to questions, but somehow, anyways. Yes, Himanshu.
We receive a question, one from in a registration form, that someone asking that how core branches student can shift toward the machine learning and data science. What hurdles they can face?
Yeah, can you repeat it again? Sorry.
Yeah, someone asking the question that how core branches students can shift toward machine learning and data science. What hurdles they face?
Yeah. So see, normally, I mean, this is what I believe. It's not a matter of choice anymore. Everyone will have to understand later or sooner what artificial neural networks are, I mean, artificial intelligence is, and what is machine learning, because these two very strong areas are affecting all the aspects of engineering and otherwise. Okay. So, so definitely there is no choice. First thing. Now, the other thing is hurdles in understanding these things. Definitely, for now, it appears to be very difficult thing. but with time, things are getting much easier and simpler. So we'll be working with natural language processors, and it'll become very simple in times to come. So the only thing is someone should have interest into it, and with the interest, you can easily, grasp things because it is getting simpler these days. It's quite simple, believe me. Uh, there are many platforms. If you start working with Python, it becomes very easy. With just one command, you can actually implement the entire AI algorithm. Yes, please. More questions.
Okay, so I hope participants, you have any questions? One more thing, we have one more session with the sir on 13th January at same 9:30 a.m. So you can ask question in that session also. Okay, sir. I hope we wind up the session.
Very good. 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 Thank you. Thank you much.
Okay. Thank
Yeah.
you, sir. Thank you very much.
Yeah. Bye bye. Thank you very much.
Bye. Uh, Participants, we have the next session at 11:30 a.m. and the link will be the same. Next session we have at 11:30 a.m. The link will be the same. We have 13 minutes break. Then we will continue the next session at sharp 11:30. The resource person is Dr. Abhishek Kumar. He is also very expert in artificial intelligence. So keep logging in this meeting. We will start at sharp 11:30. Thank you very much. And you are also ready with your questions if you have. We can ask, try to cover your questions with the every experts, and we try to, we can say, clear out the doubts related to the artificial intelligence and machine learning. So keep logging. We will again keep in touch at sharp 11:30 with the next expert, Mr. Dr. Abhishek Kumar. Thank you. Meanwhile, if somebody having any questions, any doubt, or any something related to this STTP or anything, you can ask anybody. So attendance is automatically we are taking. Okay, someone is asking question why machine learning more widely used for the medical diagnosis. So Lochan, we will cover your question in the next session because sir is left, and so attendance, can we already taken the attendance. We will take automatically attendance in our system and we will record that things. Okay, thank you. So anybody else wish to ask something? We will, in the same link, and on the same link we will again meet at 11:30 a.m. Attendance is taken, Vedant. Okay.